Okay, today we are going to look at the standard minimization problem by, first of all, graphical approach, later on duality and the Excel solver. Okay, for example, solve the following linear programming by graphical approach, where the problem is minimize z equal to 20x1 plus 40x2 subject to the constraint 36x1 plus 6x2 greater than equal to 108. The second constraint is 3x1 plus 12x2 greater than equal to 36. The third constraint is 20x1 plus 10x2 greater than equal to 100, where x1, x2 are greater than equal to 0. To use a graphical approach, we need to plot that, the region bounded by these three constraints. To plot that graph, first of all, we have to let the inequality equal to equality so that we can plot that three linear graph and then find the region, overlapped by these three linear graph. Then that will be the feasible solution region. From that, we can obtain the corner point and then plug in the corner point into the objective function. And then we can find the minimum value of z. So that will be your optimal solution. So first of all, we focus on the first constraint. The first constraint, 36x1 plus 6x2 greater than equal to 108. First of all, we can I'm going to write something. First of all, let's x1 equal to 0. So 36 times 0, this is 0, plus 6x2 equal to 108. So x2 will be equal to 108 divided by 6, which is 18. So the point is actually x1 is 0, x2 is 18. Later on, we let x2 equal to 0. So we left 36x1 equal to 108. So x1 will be 108 divided by 36, which is 3. So x1 is 3 when x2 is 0. So we obtain 1 point, 2 point. Then we can connect it. Since this is a linear graph, we can connect these 2 points to get the linear graph 36x1 plus 6x2 equal to 108. The second constraint reads 3x1 plus 12x2 greater than or equal to 36. So we'll set 3x1 plus 12x2 equal to 36. So first of all, we let x1 equal to 0. So 3 times 0 is 0. So 12x2 equal to 36 means x2 is actually 36 divided by 12, which is 3. So x1 0, x2 is 3. You got the third point. Similarly, when x2 equal to 0, we left 3x1 equal to 36. So x1 is actually 36 divided by 3, you get 12. So when x1 is 12, x2 is 0. Connect these 2 points, you get the second linear graph from the second constraint. The third constraint reads 20x1 plus 10x2 greater than or equal to 100. So we let the greater than equal become equal sign. Then again, we let x1 equal to 0. So we have 10x2 equal to 100. So x2 will be 100 divided by 10, which is 10. So this happens when x1 is 0, x2 is 10. This is the fifth point. Later on, when x2 equal to 0, it left, x2 0, left 20x1 equal to 100. So x1 will be 100 divided by 20, which is 5. Then connect these 2 points, you can get the third linear graph. Finally, so you see, you check back this one. The third graph 0, 10, 5, 0. 0, 10 here, 0, 10, 5, 0. So this is a third constraint. From the third constraint, connect it. And the region is, for standard minimization problem, the region is greater than. So mean, up to this line, all here, greater than is the upper part, greater than, including everything. Okay, later on we look back. Okay, the second constraint, where's the corner point there? 0, 3, 12, 0. Okay, 0, 3, and then 12, 0 here. So this is the second constraint. Okay, the second constraint is also greater than. Okay, greater than, let's say I change the color to blue. Greater than. Okay, the region greater than this. And also everything greater than this. Okay, in upper part. Okay, so the first case constraint 0, 18, 3, 0. 0, 18 here. 0, 18, 3, 0. Okay. The region is also greater than, I put greater than, and this one, greater than, put greater than. So the feasible solution region is actually overlapped by 3 graph. So this one, okay, this is only, okay, the red color. This one only the blue color. Okay, blue color. So this is actually nothing. So this, okay, is only red color. Okay, so this one cannot, this one cannot. This is only 2 region, blue and green. This is only green. This is only 2. So the correct region is, okay, okay, we erase everything. Okay, this is empty. Okay, and then this reason, this one cannot. This is only 2 region, cannot. Okay, this is only, right, cannot. That's right. Lastly, what we obtain is here. Okay, you check back. Okay, this region, okay, greater than, and then this one overlap with here. This one cannot because it's only this one from the third constraint. This region cannot. Okay, and then this region is only, this one also cannot. Okay, this is totally nothing. This is only one. Okay, one region cannot. Okay, this one so this one, okay, you see the feasible solution region left is here. Okay, when you check back is, okay, 3x1 plus 12x2 greater than equal to 36. Okay, this one not, okay, inside here not included. Because here, because this is only one region. Okay, this K region is actually only this line and this line, not included this one. So, okay, that's why, okay, what do you exclude? Okay, this region cannot include. Okay, this one is only, okay, greater by the second constraint. This one cannot. This is totally not. Okay, this one also one region only. This one is, okay, from this graph only. So the feasible solution region is a shaded here, shaded. The cross one, this one cannot. This one cannot. This one cannot. This one cannot. Okay, from the feasible, okay, solution region, we see we have, okay, one corner point A, which is 0, 18. Okay, and then B, and then C, and then D, you can read directly 12, 0. So we have to solve, okay, to get the corner point B by solving the equations, okay, which is, this one is, okay, 20x1 plus 10x2 equal to 100. Okay, and then with this line, which is 36x1 plus 6x2 equal to, okay, 100, 08. So mean to get the corner point B, you solve 36 x1 plus 6x2 equal to 100, 8, and then solve the 20x1 plus 10x2 equal to 100. Okay, this line and this line. Okay, I will directly use a scientific calculator to solve these two simultaneous linear equations. Okay, I will go to the equation modes, simultaneous equation. Okay, this model you can solve up to 4 simultaneous equations, but in this case we just need 2, so I select 2. Key in the coefficients, 36, 6, right hand side 108, and then 20, 10. Okay, I think key wrongly. 10. The y is x2, and then 100. So we get x is 2, y is 6. Is it correct? X2, y 6. So we get the point B is actually x1 is 2, y is x2 is 6. Okay, and then to get the corner point C, okay, you need to solve this equation is read by 20 x1 plus 10 x2 equal to 100. Okay, C with this equation, okay, is 3x1 plus 12x2 equal to 36. Okay, so again, okay, I input, okay, a new, okay, linear system 20. Oh, actually 2010 already have. I just need to input, okay, the other way. This is 12, and then 36. Go up 3. Because, okay, this one and this one same thing. So I just need to change the first equation to 3x1 plus 12x2 equal to 36. The second equation already input while finding the, okay, corner point B. Okay, so I obtain x, which is a x1, which is 4, y, which is a x2. So mean 4, 2. C is actually 4, 2. Alright, 4, 2. Okay, then putting all the corner point into a table here. 4, 2. Okay, starting point, okay, 0, 0. Of course, we obtain 0. Okay, and check back. The point A, 0, 18. 0, 18. B that we solved just now, 2, 6. C is 4, 2. B is 2, 6. C is 4, 2. Okay, D is the last corner point, which is 12, 0. Okay, and put into your scientific calculator to calculate the profit. Sorry, not the profit, the objective function z. So you go back to the computation modes. Okay, input 20. Okay, x1, let's represent using the variable x. You notice your calculator, you have a, b, c, d, e, f, x, y, m. X1 I represent by x. Okay, and then x2 I represent using y. So the red color, you need to press alpha. So 40y. Calculate. Okay, first of all, okay, x0, y0. So of course you get 0. Okay, later on, calculate for, okay, corner point A. Okay, you can let's calculate or equal. So x is actually 0, y is 18. Okay, hold on. Okay, where's my function already? Okay, and my 20 alpha x plus 40 alpha y. Okay, calculate. So now x, okay, the x is 0. Okay, go down. Y is 18. Equal one more time. So you get 720. Okay, and then you can calculate again. B, x is 2. Okay, y is 6. So you get 280. Okay, calculate again. C, x is 4. Okay, y is 2. So you get 160. Okay, calculate again. D, x is 12. Y is 0. So you get 240. Okay, so from the z value 0, 720, 280, 160, 240. So this is the minimum. So the minimum value of z, which is 160, happen when x1 is 4, x2 is 2. So this is just indicate this is not multiplier. So mean the minimum cost is actually at point C when x1 is 4, x2 is 2, where the z is 160. Okay, this is using graphical approach. In the next video, we are going to solve the same problem using duality. Okay, with this, thank you for your attention first.